James, without further ado, please take it away.
James Harris from the Bendigo Bank. Today, I'm going to do a bit of a presentation on some work that we're underway with on SVC 8219 and setting up 3-site replication. And we're going to be using CSM as our orchestrator for the automation of that 3-site replication. Now we'll just see if I can get this to go in the right screen. That works out well. Okay, so we'll start off with a bit of an introduction and a background to why we're doing it and why we're presenting this scenario. A little bit first of all about myself. I've been working for Bendigo Bank for 20 years, over 20 years actually. I'm an active member in the Storage Technical Client Council. For those of the, I'm assuming we might have a few members here today. My background really is in data resilience and recovery, those architectures around that. My primary technical expertise has been within IBM enterprise storage and virtualization of storage, software-defined storage, virtualized SAN technologies. And mainly the last probably 10 years, most of my work has been around extensive enterprise infrastructure solution design, architectures, data center design, and that sort of focus. As you can see from our organization, we run a number of brands, we have a number of products, yeah, we're just, a lot of people aren't aware that we're quite diverse in what we do. That's hopefully going to click. Yep, it is. So the data centers, why do we need more than 2 data centers? I mean, we've got 2 highly available, high performing, high standard data centers as it is now. Our biggest problem for considering a 3rd data center is obviously proximity. Now, we've heard only too many times natural disasters taking out entire cities, and even more, unfortunate things like, terrorist attacks like the 9/11, where if your proximity, if you've got 2 key services too close together, you're really running a risk. Now, we don't run our data centers in shipping containers, so we sort of just can't really pick them up and just drive them away from each other. It's quite difficult to do when they're bolted to the ground and concreted in. So for us to deal with a proximity concern, we really have to consider a 3rd site. And so we looked at this for our organization quite some time ago. It's been a hot topic for many years, and 4 years or so ago we implemented a 3rd site, and that 3rd site's primary focus was to protect all of our core customer data in the event that the 2 primary data centers were to be destroyed or become unavailable. This met our compliance requirements at the time, and we've been quite happy with that solution. Our 3rd site was actually in another state. Now, over time, it became clear that not only do we need to protect our customer data, but we really wanted to run the whole bank from that site. And although the site is well set up, and it runs some of the technologies that we'll touch on today already, we didn't really have the capacity to grow at the site, and we couldn't run the entire bank from that site. So we're now doing a phase 2 approach on this particular project 4 years later, and now we're looking at relocating the site and providing a 3rd site where we can really run the whole bank and all its functionality, even if the first 2 sites would become unavailable. So we have a number of systems, obviously, in scope when you start talking 3-site replication. The storage team is a small team. I touched on this just before the presentation. There's only 3 of us specialists that run storage services for the bank. We look after all the core fiber SAN network and all of those products that are on the screen there. So although we don't do operate and maintain sort of the Z processor, we're involved with its connectivity when we do uplift, DS8000 definitely. We're involved with architecting its connectivity, replication, and maintaining it. VTS, mainframe virtual tape library. There's a lot of products there that obviously we've got to consider when we start talking 3 sites. Now, the enterprise products, or the mainframe products especially, we can probably highlight these things. Your Z processor, your disk subsystem, and your VTS, they're already very capable of 3-site, whether it be a VTS grid or multi-target PPRC or cascaded metro global mirror like we do now on the DS8000. Natively, these things are quite capable of 3-site replication. The problem comes really in the sparse, diverse range of open systems products. You know, these things over here, all of this mid-range storage and the virtualization of it. So we introduced software-defined virtualization sort of for our open system storage way back in early 2000, and what have we been running? Probably 16 years, so 2004 thereabouts. So we've been virtualizing all of our mid-range storage from day dot. And this product here has become very powerful. We have a very the SVC, that is, we really don't provision any mid-range storage unless it comes from the SVC. But the problem with getting all these products, you know, to replicate 3 sites is we've also got to maintain everything in the middle. We've got to keep it running. We've got to be able to maintain its ongoing BAU requirements and keep it online 24/7, as well as extend it to a 3rd site, and that's quite difficult. So Spectrum Virtualized, which is the focus of this discussion for the difficult piece, we're on 8.2 code release, and natively we only have 2-site support. So with 2-site support, we've had discussions over the last couple of years with various IBM technical people and really try to work out how we could get our open systems data safely synchronized to a 3rd site. So we looked at what we need to do, and we come up with sort of 4 ways we could tackle the problem. One was to develop a 3-site solution on the current release of code. One might be to look at a current, because of the close proximity of our data centers, actually just apply an enhanced stretch model and make it one big logical site. And that allows us to then use all of our copy services to the remote distance site. So that would be a nice option. Look at the new code release, the announcements for 8.3.1, which have got 3-site support, and maybe do a code uplift and then go down that new model of using the new technology. And the 4th one, which is probably the least favorable, would be to sort of migrate out of that sort of software-defined or virtualized environment and put a lot of the core stuff that we need replicated back into an image mode disk and use back-end native 3-site replication. So in other words, have the DS8000 or maybe an A9000, although we don't have XIV technology anymore, but that sort of thing. Use the back-end controller to maintain the 3-site replication, but that's really clunky, and operationally, if you're trying to extend vDisks and do things, it would be an absolute nightmare. So naturally, we've come along and looked at option 1, and with all those options, we had pros and cons. So I'm not going to go through each one, but these are the main advantages that we come up with for sticking with the same code release. The bank very much is about stability first, and we've had our 8.2.1 code stream very mature in the bank. 8.2 has been around for a while. We're very happy with it. The combined version 8 and 9 of that code stream have been what they called deemed hardened for us. Now the term does differ. I think some of you guys might call it a golden code level or a golden image, something that IBM pretty much says is stable for you to run in your core business. It's been out in the field for some time, and they're quite happy with you to move to it. So we're very much go through the process of getting our code releases certified now before we deploy them, because we want to make sure we don't pop up any nasty Easter eggs that we don't want to find all of a sudden and have something fall over. So the other thing is our current SVC cluster has 3 I/O groups in production at both sites. It's a mixed hardware cluster. We're still running some DH8 hardware alongside SV1 in that cluster. We do have multiple SVC clusters, but the production one is mixed hardware. And we know the 8.2.1 code release supports that hardware. And even though 8.3, we could lift up to 8.3, we just knew it was stable here. We had no issues. It's been operating for quite some time. The other thing is if we stick with this code and we develop a solution, we can just leverage the native concepts that we're really that are mature, and we really understand all the commands. We understand how to file them over, how to file them back. There's no new structures that we have to learn. So they were obviously all the pros, and the cons there. Naturally, no 3-site support natively in the product. There was no integration or scheduler or orchestrator that was integrated in the product natively. We're running legacy storage pools at the moment. We're running data reduction through real-time compression for quite some time. I've done some presentations on that. We've been running that for quite some time, but last year we backed a lot of that infrastructure out, and we're running traditional pools at the moment. And the long-term goal would be to go into a data reduction pool moving forward. The problem with having legacy pools is this solution here does require some incremental snapshots to be taken to get the third site synced up, and that requires capacity. So we've had to roll on some extra capacity on the floor at the site that we're replicating from. So that's a definite disadvantage because it's cost. Expanding the volumes and maintaining the site moving forward and keeping it all consistent is reasonably complex. I'll touch on that as well. And of course, we need to thoroughly test this solution before we deploy it to production. So I'm going to go through our lab and just, we're in the middle of deploying production as we speak, just to let you know where we're at. We've just finished a design phase of this new site, and that was the last week it finished. In that design phase, we went through this lab process, and this is why I want to present this. I have had some discussions. We might do a phase 2 of this project, of this discussion, and see how we went after we went live in production under load, and we can do a follow-up. But at the moment, this is all about how we built it, how we've orchestrated it, and how the lab looks. So our lab consists of 3 separate SVC clusters, single IO group each. They're all DH8s. They're all running the Spectrum virtualized code level of 8219. The backend storage are 2 9843 Flash 840 controllers. They're fully populated with 2 terabyte FCMs, roughly 18.7 terabytes usable each. Each flash system is running a 1526 code level. Site A has access to a full controller, 18.7 terabytes. Site B and Site C, the second controller we split and allocated it to the 2 separate SVCs, so they've got 9.3 terabytes each. They're all running data reduction pools, so that way we'll have tested data reduction pools at the same time as testing this architecture. Old switches, old everything, it's just stuff we've got left, old production infrastructure, right? So we built the lab out of 292.16 switches running really old SAN OS, 291.20 switches. We set up ISLs between the switches and have 4 by 2 gigabyte ISLs between them. So that simulates 8 gigabit of bandwidth between our primary and far sites. We have 2 CSM servers. These are running actually on AIX and they're actually going to be our production servers. We're going to continue using these CSM servers for the live production environment. We have 1 active and 1 standby running on AIX 7.2. So here we have the 3 SVCs, and in some social circumstances, having 3 partnerships is frowned upon. But unfortunately, for this to work, we really have to partner these 3 SVCs, and without that done as the first step, you're not going to get anywhere. So most people, if you're already running 2 sites and SAN replication, you're going to have SVC1 and SVC2 partnered up already. So that the trick there is you're going to, when you introduce your new 3rd SVC, and by the way, these are all fiber channel connected, you'll see. Actually, if I can get a laser pointer up, I think I can get one up to point. Yeah, that will work. So you can see the type here is FC and the type here FC. And if you list a partnership on any SVC, you'll see the local and then you'll see the 2 remotes, and you'll see the local and you'll see the 2 remotes. So we're ready to go at this point. All these SVCs are happily talking to each other. They're fully configured and can start remote copy services between each other. That's the first step. The second step is to decide how you're going to how are you going to form your replication. Are you going to replicate in a star or a cascade topology? So with a star topology, essentially you're getting your source data and you're replicating it to both your near site and your remote site at the same time. The same data is used as a source and it's replicated out to 2 separate targets from the same site. With a cascade, and we've sort of been doing this for some years at the moment with a Metro Global Mirror from our sites on mainframe, you're going to replicate from your primary site to your local near DR site, and then you're going to get another replication relationship set up to go from the DR site down to your remote site. And that's nothing wrong with that. We had to make a decision how we're going to set this up, because like I said, we had traditional storage pools, and wherever we do that 3rd leg, that 3rd copy, we needed to have some additional storage. So we've decided to go with the star topology, and we've put the additional storage in our primary site A, and that's where we're going to present some flash copy capacity, and we're going to copy that down to our remote site. The implementation steps, Now, I've highlighted some of the lines in green because if people have already got two sites set up, they're irrelevant. But essentially what we're going to do in our lab is we're going to create a primary volume and an auxiliary volume at site B. Then in black there, we're going to create the third, so we're going to create a flash copy target at site A. That will be used as a source for either a metro mirror or a global mirror copy relationship for the remote site CDR. We're also going to create another volume at the remote site for an auxiliary change volume, which we'll talk a little bit about for consistency protection. After we've got all the volumes defined, so as you can see, if you're starting from scratch, there's 5 volumes required for 3 sites in this solution. So after you've got your volumes defined, you then need to start creating your relationships. So again, if you've already got 2 sites, you won't need to do step 6, marked in green there. You'll already have a metro or an asynchronous global mirror running from site A to site B for your normal DR operations. You will need to create a flash copy relationship from your primary volume that you want to protect. And it has to be an incremental flash copy relationship. We tried and it doesn't work. You can't have a flash copy, no copy, or a snapshot as they call it. That is a flash copy relationship with a copy rate of 0. It needs to have a copy rate greater than 0 for this solution to work. Once you've made a flash copy to your target volume at your site A, that target volume becomes the source for a metro mirror or a global mirror relationship from A to C. That synchronizes up your remote DR. The last bit there, step 9, is at the remote site. You need to configure that relationship and actually set up a change volume. Now, this change volume bit, we never had this on our first dry run of this lab. What we did is, and it's very interesting, I'm becoming quite impressed with change volumes. I know they've been around for a long time. We just haven't really seen how they work until we got to the lab. But this change volume is very simple. It's just one command. You change the relationship and you have to do it on the target SVC. You can't set up an auxiliary change volume using the source SVC here. Even though the relationship is defined on the source SVC, you need to define this change, you need to execute the command on the target site. So the auxiliary change is simply the volume. So in this case, it's JH for James Harris, Lab 1, change volume at site C. That's the standard that we've used for our naming. And the relationship name, JH Lab 1, it's a metro mirror going to site C. So once you do that, it's interesting, it automatically creates flash copy mappings for you, and you don't have to maintain them or manage them or define them or delete them or stop them and start them. And if you do an LSFC map immediately after issuing that command, you'll see there's this circular flash copy mapping. And the key stuff here is that if I can, I can do that. Down here, you can see it's remote copy controlled. Okay, and so when you do an LSFC map for change volume relationships, you'll see that remote copy is controlling these. It will maintain them for you. You don't have to manage them at all, which makes this very easy because you want to maintain consistency at the target site throughout this process. At any point in time, no matter whether something's halfway through synchronizing or you've had to stop and start a relationship, and the target volume in normal circumstances may go offline for some time while it's in an inconsistent copying state. That doesn't occur with this relationship. It's a circular flash copy, and the flash copy protects always a consistent state you can restore back to at the remote site if you lost your primary sites. So before we did this, by the way, we were running a separate flash copy manually, and we were orchestrating it through CSM, and it was another step in our automation, and it worked, but it just wasn't as neat as this, and it wasn't as slick. So yeah, if you guys haven't used it, get on it and have a bit of a look at auxiliary change volumes. And you can obviously set up a master change volume as well. You can do that at the master site, and if you set up a master change volume, that allows you to reverse the replication and maintain consistency back at the master site. So the last steps here is the CSM part. Again, you may or may not need to do the green section because your replication you have already running between A and B is irrelevant whether it's stopped, started. Obviously, it might affect you if you're cascading, but for us, we're using a star topology, so we don't really use CSM to orchestrate anything from A to B. We just define it so it's consistent with all the other relationships in CSM, and I'll show you a screenshot after of CSM. So we have to create these rules, these sessions in CSM, a flash copy to site A, metro mirror from A to C, and we have to schedule it all. So the net result is something like this. So you can see here, these green volumes are your primary volumes that you'll already have. and you'll have hosts using them through an SVC. If you've already got 2 sites set up, you'll already be doing some form of remote copy to your remote site to these orange volumes, and they'll be ready, probably read-only, standby, ready to go, to be mapped to infrastructure in the event of a disaster. So what we've built here is, you can see the third site, the grey volumes. We've created volumes here for the flash copy targets. We've created further orange volumes we'd use to recover at the third site, and we've created the extra volumes that are going to be used for consistency protection. Those snapshot volumes we just showed you here. And then this is all automated. Consistency protection, there's nothing to set up here, but we do have to create the flash copy mapping. And this is the piece here, this is the magic that automates and orchestrates the flash copy and keeps it all in sync. It has to be set up in CSM or some sort of orchestrator. We'll come back to that slide when we discuss it, but that's how it looks at a very high level. And that's a star topology, like we said. Source is here, replicating in 2 directions. So in copy services, copy services manager, these are the sessions as you would see them once you start creating the sessions. So the sessions are shown here. I'm just going to flick through a few slides. I'm not going to go into too much detail. I mean, you can do separate presentations, all these different bits of this slide deck. So it gets quite in depth, but it's not too difficult. It's just simply a matter of clicking create session. Whoops, I'll go back, create a session. It says what sort of session type. I want to have a metro mirror, and I want a failover, failback capability. You define it all behind the scenes, and all this really does is it creates a consistency group based around what you've defined, and you add all those relationships in, and you can manage it in here. You can see down the bottom, we've got a global mirror with change volumes. We've been practicing a couple of flash copies at the sources and so forth. The orchestration is actually quite simple too. I was pleasantly surprised. It was not too difficult to schedule automation as part of CSM. It's a matter of just going over to settings, click on the schedule tasks, saying that you want to create a task, and then you type a task name in and a bit of a comment. Then how often do you want to schedule the task to run? Now you can, if you go hourly, the most granular, smallest amount here is half an hour. I didn't capture actually all the options here, but yeah, half an hour is the smallest, which means you can only be snapping synchronization to your third site. 30-minute intervals is as quick as it's going to be through CSM at this point in time. You can schedule to run on certain days or set up no schedule. So you can set up a whole automation of sequences that you can manually run when you want to invoke it yourself, or you might want to call it from the CLI and use an external scheduler. I did touch on this and say we use Control M as our enterprise scheduler here at the bank. So you could do something like that. I've set up this process and some of these things, not the scheduling, but I've been using the CLI, and it's not too bad. It's because I'm a CLI person, I didn't find it too difficult to use. Once you've set up how often you want this task to run, you then start adding actions to your schedule. So when you add an action, you can put in your first command. You select one of your sessions that you've created, and you might want to suspend or stop that session. You might want to start it again or reverse its direction. There's all sorts of capabilities depending on the type of session, whether it's a flash copy or a metro mirror, and you've got different commands you can issue. So you select your command, and initially you might want to stop it, and then you then have to issue a wait state. Now the next step is to wait. So you issue a stop, and it might not stop straight away, right? Or it might be flushing out something. So you might want to wait until it becomes suspended before you go on to the next step. So you've got capabilities of different wait states of adding in here as well, which is very nice. This is just a quick text output. It's a bit hard the resolution there, but essentially this is what I ended up with, and it needs a little bit of tweaking. I originally had 8 steps, so they're in pairs. Essentially, the first thing we're going to do is our metro mirror from A to C. We're going to issue a command to suspend it, which is essentially doing stop RC consist group. We're then going to wait for the state to make sure CSM is happy that it's in a suspended state, so we won't move until that becomes suspended in CSM. The next step is we've now paused that metro mirror, the link between site A and site C. We can now take a fresh flash copy of the source volumes. Again, this works at the consistency group level. So this will be a whole group of volumes being snapped at once. And we're issuing the flash command through CSM which is basically just like a start flash FC consist group, similar sort of thing. Start FC consist group to do a snapshot. We then wait to make sure all the snapshots are available. And then we resume or start that remote link and copy all that change to the remote site. Now, this part here, the wait for prepared, it used to sit and wait until the target become available before I added consistency protection. And that's because without consistency protection at the target, the volumes essentially went offline. It was in a inconsistent and copying state. There's quite a lot of change, potentially. And the minute it becomes consistent and synchronized, it would be prepared and you could move on. But when you have consistency protection, then it's always online. Those target volumes are always being protected by that circular flash copy mapping. And I'm finding that this doesn't pause on the last step here. And it's not necessarily a big thing once you get going, but it's something that we're going to look into. I've raised it, and IBM are aware that consistency protection isn't fully integrated into CSM at the moment, but it's something we'll follow up. But essentially, that's all you should need. Pause, wait, snap, wait, resume, wait, and that's one cycle. And the most granular interval is half an hour at the moment in CSM. So in the test lab, we've run quite a lot of different scenarios, and we've got physical servers, virtual servers, Oracle hardware, we've got Lenovo hardware running under VMware. So we've sort of had to have a think about how we're going to recover the bank at the remote site. And my preference would be, for all the subject matter experts out there and the application owners to use their own sort of software replication and take all the worry off my team. But we've opted to go for predominantly SAN-based replication wherever possible. It saves obviously on software licensing. It can also save in most cases on some sort of latency on the application, waiting for a remote site to keep in sync with your primary site. So everything we've tested has been through this model, and these are the successful tests we've done so far. So we've managed to successfully sync up and replicate and recover our domain controllers. Obviously important in an Active Directory Windows environment. You have to have your domain controllers up and going. We also have a lot of SQL testing. We've done sort of a virtual server that's SQL running totally on VMDK, virtualized environments and recover them. They're pretty straightforward. That's just a VMware. You've got a VMFS LUN, you're snapping it. These are all crash consistent, right? These are as if you've just cut the power from the environment and you've powered it back on and you hope everything recovers. So these aren't quiesced or application aware snapshots. These are just under the covers being snapped every 30 minutes, and they recovered really well. Everything under VMware recovered really well. All the virtual machines that we tested, such as SQL, recovered very well. We've got a couple other scenarios though in production. We've got Windows clusters, hardware clusters, always on clusters, and we've had to think, how are we going to have recover those physical servers where when you think the operating system, their core binaries and things are on local spindle disks or SSDs sitting in a server, C and D drives and whatnot, and then you've got your data out on the SAN and you're snapping the SAN, but you're not bringing with it the actual core binaries and the server itself because it's sitting local. How are we going to recover some of these environments? So we've run through a few scenarios where we've actually added a virtual server to the SQL cluster, and we've had one clustered node running virtual and the others staying on their hardware. That cluster node in production would be configured never to fail over to. It's there as a stub to hold the cluster configuration, the drives. They can actually have the real drives mapped to them as raw device mappings, RDMs brought in, so that it knows the drives, it knows the drive letters, and it's aware of that data, and then we snap everything at the SAN level. And we've done that test and recovered that, and it worked quite well. We've also tested other scenarios where we've just had a separate standalone stub SQL server with a couple of empty drives just mapped to it that are 1 gig each, for example, just to build the drive letters and so forth. And when we've powered it up at the remote site C, we've stripped those out and replaced them with the real data log drives and everything from the SQL Server that we're protecting, and that's also worked. So we've been very happy with our SQL recovery to date. We've done also some Oracle rack. Now, in this case, our Oracle rack uses a sort of a data guard to protect itself between sites A and B, our primary sites. We don't use any SAN replication. So we've got a bit of luck there because we're not already using copy services for the primary volumes to date. We can just do a one-to-one replication, which is just straightforward, doesn't have to be CSM orchestrated, although we tested it through CSM. And we could just replicate that all the way down to site C, to the far site. We use global mirror with change volumes, mainly because of, we don't want to have any latency impact. We're probably a distance that's on the verge. We could go synchronous mirroring and asynchronous mirroring. We're sort of putting global mirror change volumes in lieu of asynchronous mirroring, mainly because we want to also not stress the link out too much with large bursts of writes and changes. So, but that's worked very well. This is outstanding. Our Cisco VoIP on UCS, that will probably kick off later this week or next week, and that's still, I'm sure we will get there with that. It's just a matter of how we're going to configure it the remote. So we've done a bit of, most of it, obviously, we are a 90% virtualized workshop. So the bulk of our core will be well protected using this method we set up in the lab. Now I'm just going to move some stuff off my screen because I'm getting some things popping up here. So now we've got to look at what issues are outstanding and what do we need to do when we prepare for migration to production. There's expanding the volumes at the primary site. I wanted to spend a little bit of time on this slide because this is day-to-day bread and butter stuff. Most of us are doing with no disruption to business. We're allocating more capacity, and it's the most common task, any storage administrator probably does from week to week. This becomes reasonably complex when you start thinking 3 sites and 5 volumes. And getting the process down was a bit of, I had a bit of a hit and miss, and eventually I came down to this sort of solution. So I'll run through it really quickly and show you, actually I can show you visually what we're sort of doing at the same time. So we might flick through a couple of slides here and see how this goes. So step one is to obviously stop the replication temporarily. We just want to pause it. So we want to do a stop RC consist group, or through CSM, you want to suspend it, and you want to stop anything from A to C replicating. And the good thing is when you stop it, you don't forget you've got consistency protection at the target. So you now have got a point in time where essentially the target has been snapped and it's sitting there quite safe. Once you've done that, stop CSM schedules, I should say. Sorry, I'm jumping ahead of myself. So you want to stop any CSM automation from kicking in and mucking around with these replications while you're doing this task. So you want to stop your AC and then get ready to remove the relationship. So if we move forward here to this slide, and if I find a slide on my slide deck, we might be able to make this work. So essentially what we want to do here is, but bear with me while I play with PowerPoint, this should work. We said stop this. That's the first step. You want to stop that replication there. The next thing is you want to remove the actual relationship that does the snapping at site A. So this piece here has to be taken away. That little circle there, that little task needs to be removed. You need to remove the link from the green volumes to the grey volumes. Now, if you've got a consistency group and you're only extending 1 volume, you're going to have to remove that 1 volume out of the flash copy consistency group to be able to remove the relationship of the flash copy mapping for that 1 volume. If you're doing a set of volumes or similar process, it can't be part of the consistency group while you're doing this. But you've got to do a stop flash copy consistency group, or stop the mapping and make sure it's deleted. You don't want any relationship there. So if we go back, now can I go back here? Yep. So we've done 1, we've done 2. So now if the metro mirror between B exists, expand B and A. So what we're saying here, now we've isolated essentially can I just, yeah, we've isolated those green volumes from the gray volumes. The green to the orange, A to B is just a normal everyday one-to-one relationship. And so really you can go through the standard process that you guys probably do now, and that is on the right-hand side, those orange volumes, we can grow them and make them bigger like that. We can add capacity, no worries. And this has been available to do while the relationship's running online for some time, depending on what code level you're on. You can now obviously increase site A's green volumes and make them the same size. And that relationship keeps running, no problem, business as usual. You can go back to your customer and say your disk expansion's done. At this point in time, it's done as far as they're concerned. They'll see the growth on the green volumes and they're protected locally on the orange volumes. We're ready to go. However, we've still got a few outstanding tasks. So if we, if I can get back here, we've done, we've stopped our CSM schedules. We've stopped the replication between A to C. If site B metro mirror exists, we've now expanded that. That's simple. Okay, this is simple, straightforward stuff. Now we need to expand site C, and this is a little bit tricky. It's not too bad, but we've got auxiliary change volumes. So we start with those first. Then we do the global mirror, metro mirror target, and then we do the global metro mirror source. So for this particular step, step 4, what we have to do here is we have to essentially remove the gray volumes out of the consistency protection, right? So the command is like, I can't remember it. No, I can find it somewhere. I'll find it. But anyway, it's, you just change the relationship and it's minus no change. Okay, so CH relationship, this is my workshop notes, by the way, for the lab when we did this. You can see here, I've done a command, stop the relationship, and we've put no change volumes for that relationship. We've removed this section, these volumes up here, the gray volumes, from being change volumes. Now they're removed, they're just standalone VDisks sitting on a target infrastructure. So it's very easy to grab those and expand them. Okay, simple. Just make them the same size as the green and the orange ones down below. Now, this particular relationship here, you can actually start this off. You can kick this. Metro mirror, global mirror off, and if I can remove that cross, which hopefully this works, you can resume that, because this is just a one-to-one relationship sitting there all by itself, mirroring. And similar to what we did between A and B, we can now just expand the orange volumes. They're the targets first. We can then expand the source. They're easy enough to do. We can expand the source. This is all running live, replicating. And then we can actually grab these consistency volumes and add them back in. And so we're here. And everything's consistent and copying. Remember the point in time when this got stopped and snapped and everything like that? These are still probably now 5 or 10 minutes behind the green volumes, which are now running live data. So they're a little bit behind. So you got to be aware of this. You wouldn't want to do it the next day or whatever. You want to do all this in one task as quick as possible to keep all sites in sync. So if we go back to this slide here, we've done step 4. We've expanded all the volumes at site C, starting with auxiliary change, global mirror, target, and so forth. And we've also done step 5, make sure A to C is resumed. And now we can rebuild the flash copy mapping. When we rebuild this flash copy mapping, it will send a full copy of the source volumes, those green volumes, from A up to C. But the consistency protection we've got in place will ensure that site C is recoverable during the whole time they're syncing up. So if you've got a really large volume, I know 4 terabytes, and you've just made a change and you've added 100 gig, it's going to send 4 terabytes plus 100 gig from scratch all the way up. And that's just, there's nothing you can do about that. So if we get back to here, the last step, like I said, would be to reintroduce this flash copy, start the flash copy, and watch these. This is at now ground zero snap at the gray point, and it will replicate all that change up here, and we're back to where we were at the start. I'll get rid of that little line. So the process is, yeah, let's say convoluted compared to just expanding a VDisk or expanding 2 VDisks. Step 6, oops, I've got to go back. Step 6 is really just doing a quick validation that everything's looking good, it's all running, and then you can resume your schedule, the automation, the orchestration for site A to C through CSM. So I've put a little notes there. There's a few things I'm going to follow up on. There's probably some risky steps in there, mainly around ripping things out from behind Flash CSM. If you're removing mappings and re-adding mappings and things like that, we're not actually rebuilding these sessions in CSM, and CSM does have a need to know certain sort of flash copy IDs, remote copy IDs, and things like that. It likes to track some of that. We didn't run into a problem, but I could see potentially if you removed a flash copy mapping with an ID of 5, then you recreated that flash copy mapping and it went back with an ID of 3. It potentially could cause some problems. For an incremental flash copy, it seems to be okay. When I look at the audit log of what CSM is doing behind the scenes, when you do a flash copy for an incremental, it's pretty straightforward. It's just doing another start FC consist group. It's simple. But I noticed when I was playing around with some of this stuff for snapshots, flash copy, no copy, it was actually deleting all the relationships and recreating them, and it sort of had a very close understanding of the structures behind the scenes. And it does say that in the red books in CSM. So if you start dabbling around with CSM, it does mention some of this. So I've got a few things there down the bottom that I've just made notes on. Rightio. So yeah, that's how to expand. Yeah, and you've got to be aware that expanding one volume is now expanding 5 volumes, and there's a bit of thinking to be had. So we're going well on time, so that's good. So what's next for us? Obviously, we've done all this in the lab. We've built the structures. We've got it all working. We've done recovery testing. We're now into our deployment phase for production. We expect around about 6 to 8 weeks. The target site will be racked with equipment. We need to get our primary site is a traditional pool. An incremental flash copy is going to double up on space. We've got a large quantity of storage to be sorting through and preparing. So the first step, which actually I've just completed yesterday, is we've commissioned new storage at our production site for us to flash copy into. That pool, we've actually decided to go with a data reduction pool to hopefully make the most out of that capacity. We haven't got a full production footprint, and we haven't doubled up entirely. We've only doubled up on a smaller quantity, about a third of the capacity. So we'll see how we go. The remote site will be built with SV2 hardware, so that's something new for us. It will be running data reduction pool from day one and running on the 8.3.1 code stream. So we're going to have some 8.2 infrastructure replicating to 8.3, albeit that we're going to be using 8.2 constructs and 8.2 methodologies of getting it there. But our target environment at the remote site will be ready and proving data reduction pools, proving 8.3.1 code stream, and be running that for quite some time for the next 6 months, so that when we make a decision to either uplift the code or change our pool structures, we'll have a good use case or good experience with the environment and know that it's quite stable and it hasn't given us any grief. So we've got to prepare that remote site and get it built. Preparation of the volumes. Now this is time consuming, and a lot of work with the guys who know what data sits on those volumes is involved, and the mid-range guys have been doing great jobs. They are going through looking at application stacks, consolidating onto a single VMFS stores wherever possible, minimizing the amount of volumes that have to be put into consistency groups. And then remember that copy services manager only works at the consistency group level. So even if you've got a one-to-one relationship and you want to put it in CSM, it will make a consistency group for that. And so what we found is we've got lots of volumes that potentially are part of the same application stack that should be flash copied together and maintained consistent. However, they're sitting in different IO groups. So when you've got volumes in different IO groups and you're starting to do flash copies and things like that, you really need to, like we said, look at them and try and get them in the same IO group. We don't want a lot of node-to-node chatter and flash copy bitmaps and tracking all that and doing snaps. We've got to get the volumes in the same IO group. So there might be a bit of NDVM, so a bit of non-disruptive volume migration going on now over the next couple of weeks. It's something that we need to do to get them in the similar IO groups ready to go. So we're not moving in between pools, we're just moving the owning, controlling IO group for the IO to another IO group. but there is a proper process. It's well documented. We've done it many times before for physical and virtual hardware. It's just a process we have to go through. That's going to take time, and we're getting there. I would say we're 80% ready to start doing this work. The scope of a replication for open systems, it's a bit vague. The numbers keep changing, but we know it's somewhere between 500 to 1,000 terabytes. So that's a sort of quantity of data we're dealing with in open systems that needs to be snapped, orchestrated, replicated, snapped, orchestrated, and replicated every 30 minutes. And it's quite a lot. You can imagine if you're trying to do that every 3 minutes or 2 minutes, it could be quite a lot to maintain and track. So at the moment, we've got sign off from the business that they realise that this third site is an extreme DR measure. We've already got a well-protected, highly available sites at the moment. So this DR is really a DR of DR. And so they've relaxed somewhat their recovery point objectives, expectations for this third site, and 30 minutes, we've agreed that 30 minutes would be the best case. It might be if you had disaster straight after snapping it and the data was all there, it could even be a little bit better, but they realize, it could blow out to an hour or thereabouts for a recovery point to be recovered at the third site. So yeah, it's a lot of data, a large footprint, and we've got to wait till the WAN links and service are in service before we really can get an idea of the load on the links. We're going to be having two 10 gigabit links, one from each site, site A and site B, coming out in terms of bandwidth to the remote site C. We've got other links in place as well, but we've got 210 for our SAN replication. And by the way, our SAN replications, we manage the Cisco network. We're using fiber channel over IP as our protocol for getting that data. So everything will be done on this at the SAN fabric layer. Support staff. So the support staff, there's only 3 of us. I think that both the guys are here. They just need to be really comfortable with the structures. We've been running labs. As you can see, I just sort of drag this screen across here. You can see this is 3 files. We've got a workshop 1, a workshop 2, a workshop 3. We've been setting up different workshops and running through all the steps, creating the environments, expanding vDisks, setting up global mirror change volumes. We're doing this in a lab. So having the lab has been invaluable to us because we can just work quickly. It's an environment we don't have to jump through change management hoops, and we really need support staff understanding this and how to fail over and fail back. But there's not just a storage team, right? We have all of our subject matter experts, our administrators, SQL, our service recovery team, which is a separate team to us who actually orchestrate the business apps, the business interaction, the technical teams, and have run sheets on how to fail over and fail back. They need to somewhat understand some of these limitations that may be imposed. They're used to doing SR failover. We run out of our remote DR site for a week or longer, including mainframe operations, core banking, the lot. We test those sites regularly throughout the year. However, testing this third site is a completely different kettle of fish for us. We're not going to test it very often in terms of it won't run live tests. It will run isolated bubble sort of style tests, isolated network tests, and that's going to be really tricky to run things with the same IPs at a remote site and have them communicate with domain controllers and not, tombstone entries for servers and all sorts of weird stuff. That's a challenge. So there's a lot of people working on their various environments, getting comfortable with the failover, failback of the new structure. So the solution load testing, as we said, really won't be truly understood until we begin production. We're looking, I think, August, September, around. There'll be 2 major phases of testing. After that period, I'll have a better understanding of how this all worked. It all sounds good in the lab at the moment, but yeah, keep that in mind. So outstanding concerns. I think I'm making good time here, so that's good. So knowing your hardware capabilities and configuration, absolutely critical. You need to know what version of code you're running, what hardware you're on, what your configuration restrictions, memory limitations, whether you've got enough capacity or you've done enough memory expansion in your IO groups, flash copy bitmaps, licensing of copy services. There's all sorts of things you need to just be really comfortable with and understand before you dive headfirst into expanding from 2 to 3 sites, or even expanding from 1 to 2 sites for that matter. So just make sure you've really got all that nutted down well. Sometimes scaling out your environment, which we've done. We're in 3 IO groups at the moment. You can scale out, add more IO groups as opposed to just uplifting from SV1s to SV2s or DH8s or CG8s or whatever you're running. because more IO groups gets you over the limitations around the number of volumes you can flash copy per IO group. It also gets you around some of those other constraints that are there. And so you may need to consider just adding another IO group to your environment if you're if you've got a large quantity of volumes like we have. I highly recommend, and I've done discussions on this before, remote and local port masking. Put it in place. You want to minimize as much chatter on your front end, back end fiber channel ports. You want those functions to be unrestricted. Keep your low latency, high performance operation running on your primary site. You don't want to start smashing it with remote copy services, feature, function, and data. So if you've got enough ports in your environment, if they're not patched in, get them patched in, patch in extra ports, and dedicate them for local node-to-node traffic, intranode cluster, and internode or remote node cluster traffic. That's your remote copy stuff. Dedicate ports for replication. I highly recommend it. There's a port masking chart in all the knowledge centers and red books, been going around for ages. It keeps adapting depending on whether you've got a 4 or 8, 12 or 16 port node type of topology, and you can balance those ports out really well. We tend to, IBM recommend sort of front end, back end a lot on their ports. You know, and the argument there is it's duplex, right? Your host does a read, so the port sends the data to the host. Meanwhile, it's getting the data from the back end, so it's doing a read from the back end. They go in two different directions. My argument to that is some hosts are writing while some hosts are reading. So hey, to me, it's duplex, but those ports are going to be doing front end and back end. We tend to just dedicate a port to back end, dedicate a port to front end, dedicate ports to remote replication, dedicate ports to node cluster traffic. And that way, if your port's flapping, hitting 100%, you generally can troubleshoot really quick, and you can know straight away what where to look for your problem. Is it a host generated problem, or is it a back end bottleneck or something like that? But important point, I can't stress it enough. The CSM CLI, yeah, look, the CSM CLI, we've played with it. I don't mind it. It's got limitations. There's no sort of task scheduling available at the moment. I did bring this up for discussion, but everything else, creating sessions, importing copy sets, and stopping and starting and doing the functions of CSM. Remember, CSM's working at the consistency group. It doesn't work with individual volumes. It won't map and unmap. It won't. When I say that, I'm talking open systems here, right? So we've had CSM running. We've now got it running on our HMCs for mainframe. There's a lot closer integration of CSM to mainframe hardware. It knows about hosts. It knows about, well, you can't even get hosts defined in CSM for open systems. It doesn't have that capability. But that said, it's been a lifesaver for us because it's just done the automation without no worries so far, and we're very happy with that. But again, just be aware that if you can't have an RPO of 30-minute cycles, then you might need to set up a CLI somewhere, maybe on an AIX or a Windows box, and use some sort of Windows task scheduling or a cron job or enterprise scheduling to call those commands at more frequent intervals than 30 minutes. You can do that. I can go in the GUI and right click and go run now, run now, run now. And like here's my live CSM environment as we were just showing it in the slide deck. You know, it's not hard to go and just wait for it to come up. Yep, it's still running, hasn't timed out. So I can go into the scheduled tasks and just go on any one of these session schedules, and you'll have heaps of them here. Make them really meaningful names and go, oh yeah, lab 3 site group. I might just action and just run that task now. So you can just drop down and run the task. So you can do it. I could click run task every 5 minutes if you want. Are you sure you want to run it? Yeah, let's go, let's run it, and away it goes. So, you know, it's just doing its thing, and you can see it's running. So you don't have to have 30 minutes, but it's only if you're using the inbuilt scheduler, it's 30 minutes. It's as granular as you can get. What else we got here? Scope. Yeah. Copy service relationship. Yeah. Okay. So obviously the replication, if it's from site A, additional storage. Yeah. So for us, we need additional storage capacity. You may not. If you're already running a data reduction pool, then incremental flash copies, which will potentially generate a full copy, will just dedupe against the data you already have in your pool, and you won't have a lot of pool growth. We've seen in our lab, data reduction pools have done great things for us. I know, Andrew, we did touch on this before, and if I can open up again quickly, I'm just being mindful we're getting towards the end of the hour. Our target site, which if I just quickly log in, excuse me.
Sure, by all means, James.
Here we go. I'll just bring it across here. So we thought we'd just show this. I know a lot of people will really want to get excited around DRP, so why not? Let's show it. LSM disk group. So this is our target site C in the lab. And I was highlighting the point that we only had half a Flash 840 of capacity, 9.3. We've actually got 42 terabytes of volumes we've carved out of that using only 2 terabytes of space. So this is what data reduction pools are doing for us, especially in the lab. We can just keep spinning up, snapping, flash copying, setting up more copies, and we're consuming very little space. So for a lab, it's just fantastic. We've been able to do quite a lot. And if we look at the volumes, we've got snaps of various VMware labs running live VMs. We've got SQL servers with RDMs. We've got the UCS lab replicating a number of different workshops I've been running with Mariano and Kartik. They're all, target volumes. Some of these are quite small naturally, but some of them are quite big. They're all got data in them, and yeah, the data reduction has been fantastic. It's really allowed us to freely snap and build a large environment in a very little bit of space quickly, and without having to roll on a huge footprint of capacity. I mean, the Flash 840s are only 2 RU, right? And we only got 2 of them running this whole lab, 3 sites, and we're doing heaps of work here. So for us at the moment, we're running traditional pools in production, and then so you've got to be mindful of your pool structures as to whether you need to roll in extra storage capacity or not. So migrating site A, this is the point I was trying to make. Next year, we'll probably seriously look at migrating our site A and B production environments, traditional pools, into DRP. It's going to save us the need to bring in extra storage, because you've got to think at the moment, if we fail over from A to B and B is now the source, we haven't got a flash copy pool sitting at B. So we are really dependent. It's fine on a test when we're reverse replicating back to A, because we can still take the snapshot of A. That's where I put the storage. I've just commissioned it. But if A was to blow up, I've got no storage at B to build the flash copies. And so we, at this point in time, phase 1, we're not building the rules from B to C. We're only building the rules from A to C in that star configuration. And the last concern I have, and I've mentioned this, is CSM. CSM has an active standby scenario. And if I go back to CSM and just log out, I could have, you'll see here, do you want to switch the alternate server? It says down at bottom, BCP CSM1. So I can just click on that and switch over the alternate server. They are kept in sync automatically through CSM, all the data. We do back up the configuration, but it's a standby. You can swap it over. We've tested the standby, it works well. However, if we lose site A and B, what do we do at site C? Where's our CSM? We don't have one. We really need a second standby down there. So we've got to come up with a solution where we're dumping the backup and extracting the backup and sending it down to the remote site ready for a standby CSM server can restore the current configuration into to do CSM automation if we're going to use CSM at that third site. So at the moment, the third site will be very hand, stop, start, manual processes and so forth, no CSM orchestration once we go to the third site. But yeah, so that's a point that I have. And I think that if I click on that, that will be probably the end. So I'll hand it back to you, Andrew.
No, James, this has been fantastic. There were a couple questions that both Barry and Brian were fielding a little bit that go directly to your environment. So Barry or Brian, feel free to chime in, or we can read them off in order of how they came in.
So I think there was, if we close off a couple of the ones that we couldn't answer, and we can always go back and review the other ones. So one of them, James, someone was asking what type of bandwidth utilization you've seen during the testing within the 30-minute interval. The only comment I made was I wasn't sure how far you'd scaled up the testing, and I guess it's going to really be once you go into production that you'll really know what kind of bandwidth you're sending.
Yeah, okay, that's a good question. So you've obviously got throttling mechanisms from remote copy that you can configure. I've installed these environments for now with everything set to default. I'd have to go back and check those throttling settings, but we've got 4x2 8 gigabit connections set up as a port channel between the A site and the C site in our lab. Now we did notice, for example, when we stopped replication and let the SQL guys test their remote site replication, they said they were done and finished. I forgot to resume it, start the automation in CSM, and a couple of days went by. I thought, oh, I forgot to do that, and I started it. That was a good test because when I ran that, it was way out of sync. And, it took sort of a few hours to sync back up all the changes. Every 30 minutes, though, we probably haven't got that production load to really have a good feel yet on, you know, are we going to get the change data down that link, 20 gigabit in a cycle? Time will tell. So I haven't got a lot of numbers around that sort of stuff. And obviously, and the last thing is, yeah, we could change and uplift our you know, remote copy throttling, I suppose, and make it run a bit faster. That's the question, but yeah, I haven't got a lot of hard numbers on those.
I think you got that. And by the way, there was another question from Robert, just making sure it's all FC, or are you using something else as part of your topology?
IP-based replication. Obviously, it's FIP, but in terms of what the San Volume controllers or whether you use whatever you're using, we're using fiber channel. So all of our, and we can just bring across the SVC here. So LS target port FC. Now you can test my knowledge. So we can see target ports I've set up are just straight out. We've got those ports there, LS port FC, and we can see what we've configured. I've configured some port masking for local and remote replication, 1 port per node on each fabric. So there's 2 ports per node, sorry. So I'm using, out of 4 ports per node, I'm using 2 for replication services and leaving the other one for front end, back end, but it's 100% FC. And the partnerships, yeah, that's what I was saying before, the FC partnerships.
By the way, Brian and Barry, thank you so much, as well as Mark, for taking on some of those questions and answering a whole bunch. That was fantastic of you guys. Kurinashi-san, you answered a great question earlier. Was there anything else from Team Japan you wanted to bring up while I've got James on the phone? Anyone else, please? We've got a couple more minutes still. I want to make sure, and otherwise, we'll end the call.
Thanks for doing this, James. Much appreciated.
Yeah, I don't see anything else.
No problem. No problem at all, guys.
So thanks very much for this, James. And if you want to, please, you talked about earlier about giving us a follow-up session when you get to your next series of steps. I would love to host that. Let me know. I'll be glad to.
Yeah, sure, will do. It's a bit exciting. Like, obviously, the proof will be in the pudding. Just we're at the stage now. We've decided to get IBM to ship the target storage infrastructure to our primary site. So we're going to lay down a footprint on connected up to our production site A, lay down a footprint to site C. This is where it's happening over the next month. So that will be interesting. And we've got to be very careful in our design and our fiber channel zoning, because it's got to be able to be disconnected, boxed up, couriered a long way away, and connected back up and still operate. So, and still partner with our primary site. So that's got some forward planning. But once it's up and going, and then it's keeping itself in sync, it'll be very interesting to see how this scales. This is obviously. It's all new territory for us, and I'll be more than happy to do a bit of a follow-up once, you know, later in the year, or once the dust settles, because our testing phases will be pretty busy now in implementation through till end of sort of August, start of September. So after that, October, November, there might be a window where we can revisit this if people are interested.
That sounds great. I do have one last minute one. Go ahead, Tom. Take it.
So James, is there a plan to lower the RPO?
Well, look, for our core banking services that are using DS8000, they'll be using multi-target PPRC. So we're going to have one synchronous local replication, one asynchronous, which means it's going to be only seconds behind for core banking. So we've got other services that we've already identified, Oracle and some other things that are not using SAM-based replication now, that can also leverage a very low RPO, because it'll just be a one-to-one replication. But we do have all of our virtualized environment, and all of our virtualized mid-range environment is already replicated between the sites. So this is going to fall into this whole presentation of snapping and sending to the remote site every 30 minutes. I would think we will revisit the RPO, and it will be interesting after we do our first round of service recovery tests at the remote site. If people start saying, "No, look, this front end application is actually too far behind the back end data," or whatever it might be, we need to have more granular snaps and a better RPO, then we might have some use cases where we're going to have to automate through the CLI, and we'll initiate those scheduled tasks manually from an external scheduler. And yeah, we might make them every 15 minutes or 5 minutes or something like that. We'll leave our global mirror with change volumes, which are 1-to-1. We'll leave them on a default 300-second cycle, so they'll be in 5 minutes, which will be nice for open systems. That will be all of Oracle, but there's some other bits and pieces we're talking at the moment with the SQL DBAs. They would like to have a little bit more granular RPO already. So yes, the answer is yes. I think we're going to need closer than 30 minutes, but 30 minutes is been, luckily we got that sort of signed off because we just had to put the worst case scenario, and that was the best scheduling interval we could get on CSM. And we just said, are you guys aware there's going to be some data loss at site C, and it could be 30 minutes to an hour, and they're aware. That is, the business is aware.
Excellent answer. Well, I don't see any other questions in the queue or anything like that. So James, please have yourself a great weekend and day. Thanks for all this. Everyone else, please, if there's anything else afterwards, send it on in and I'll be sure to get it to the right folks. Thank you, everyone.
Thank you.
Thanks, James.
Thanks, James.